Okay, so in this short section, I want to quickly talk about some shapes of distributions. And we have already seen various distributions, like earlier when we looked, for example, at quantitative data of GDP per capita. We have seen that the distribution looks a little bit like this when we do a histogram. So that one would be considered to be skewed to the right. It doesn't look nicely like a bell-shaped curve. And also here, we have seen different kinds of distributions. So there is a certain terminology associated with distributions, and that terminology can either refer to the, how do I call it? One is, the official term is kurtosis, and kurtosis assumes that the distribution is symmetric. So, but it could be very narrow in the middle, and whenever it is very narrow, we call that leptokurtic. But whenever the distribution not is symmetric, but it's very flat, we call that platykurtic. And if it looks nicely bell-shaped, then we call that mesokurtic. Probably more important, I feel, is the issue of skewness. So we have seen earlier that the income per capita data is skewed to the right, and that is what we call positively skewed. So whenever your data has a long right tail, then we call that positively skewed, and if your data has a very long left tail, then we call that negatively skewed. And if it's nicely bell-shaped, if it's symmetric, we call that normally skewed. So in the next video, when we talk about scatter plots, you will see why the distribution of data matters a lot, and why data scientists or statisticians or econometricians are typically concerned with working with normally distributed data, which means mesokurtic and normal skewness or symmetry. But that should become clear if we take a look again at some earlier data and discuss scatter plots.